All right, hello everyone. This week we're going to kick off chapter 19, which focuses on a new functional group and a new set of reactions for those functional groups. These are aldehydes and ketones that we're going to be going over this chapter. First thing we're going to do, let's just introduce these functional groups, right? Um, the functional group itself are called aldehydes and ketones, but they contain a very specific type of bond, which is a carbonyl bond or a carbon double bonded to an oxygen. Okay. Both aldehydes and ketones contain these carbonyl groups or carbonyl bonds. I tend to refer to them as carbonyl bonds, not carbonyl groups. But so do many other functional groups, right? So carboxylic acids, esters, etc. Aldehydes and ketones, we're going to kind of lump together separate from those other ones. And we'll see why in a second. There's a good, next chapter rather. There is a good bit of overlap, but nonetheless. What distinguishes an aldehyde from a ketone? An aldehyde very specifically has a hydrogen that's bound to that carbonyl carbon. Whereas a ketone, those are both carbons on either side of that carbonyl bond, okay? The simplest ones that you just kind of know the common name of because they, the formal naming system. I guess what I'm trying to say is that this IUPAC name for this guy here is formaldehyde. It's not going to follow the sort of normal nomenclature rules that we see for aldehydes. It's got its own special name. Same with acetone. It's just got its own special name. They're so widely used, and they were so widely used before the IUPAC system was even developed, that those common names just stuck. Okay, so nomenclature. Let's go through each one of these individually. We're going to do aldehydes first. In a lot of ways, it's the exact same as what we're used to. We're going to have to find the parent chain, find the substituents, number our parent chain, and then set everything up alphabetically. With aldehydes, so we're going to start with aldehydes. Notice we have a new ending or a new suffix for our names. Butane, when it's an alkene, becomes butanol. So an ending of al signifies that it's an aldehyde. Just like any of our other special functional groups, we want to make sure to number our parent chains such that that functional group is included. So it's not necessarily going to be the longest set of contiguous carbons like it was when we just had a simple old alkane. We're going to do it where we make sure to include that functional group. And then the numbering scheme here is important because you're always going to start with number 1 as at the carbonyl carbon, right? So again, specifically talking about aldehydes. I guess one more thing I want to point out. This is not one, This is not one butanol. It's just butanol. My al and my all. I'll be even more dramatic with the al ending so that we know we're talking about aldehydes and not alcohol. So butanal. It's not one butanal, it's just butanal because since this is an aldehyde, we know that that functional group is always going to be located on that terminal end, right? So it's always going to be on carbon 1. So kind of nice thing about aldehydes, you don't have to worry about including the location of the aldehyde functional group in the name. We are still going to number if there are other substituents, we will have to include them. And again, we're going to number such that that carbonyl carbon in the aldehyde is always carbon 1. Okay, so here's my correct numbering scheme versus my incorrect numbering scheme. Again, I'm not going to include, or I'm not going to start or end with that carbonyl carbon. I'm going to make sure to start with that carbonyl carbon. So just to go through, this is actually kind of a tricky one here. So let's see. So we have a methyl group, a bromo group, and then of course that alkene, which is going to be also a suffix, right? So I'm going to have to put the suffix at the end there. So this would be 5-bromo, 5-methyl, hept, 6-N-al. All right, I got to include, I guess actually I could have also done 5-bromo, 5-methyl, 6 heptanal, because I don't have to worry about numbering that al group, that al suffix. It's always assumed to be on carbon 1. Okay, with ketones, our ending goes from just an E with we were an alkane to now the "one" ending, so butanone. Unlike the aldehyde, we do have to include the number. So this case, this would be 2-butanone, right? 1, 2, 3, 4. And yeah, so just like previously with our other suffixes, you can put it at the end if there's just one of them, or you could put it in the middle. Either of them are accepted in the IUPAC numbering scheme. Remember, this sort of way over here looks weird, but if we're stacking suffixes, so for example, an EN of an alkene as well as the ONE of an aldehyde, you have to put them both in the end. So we'll see an example of that here in a second. And just like all of our functional groups, you're going to make sure to number your chain in such a way that your functional groups has the smallest numbering scheme, right? So it wouldn't be correct to have numbered in the other direction. Again, we sort of mentioned some of these common ones that you need to know. Formaldehyde is one of them. Notice that's the simplest possible aldehyde, where both of those groups on the carbonyl carbon are hydrogens. There's acetaldehyde, which is just one methyl group, but it's still an aldehyde, right? Different from this would be acetone. And then benzaldehyde is one of the ones that we learned about in the last chapter, I guess, as being one of those special benzene parent chains. Okay, so now just to complicate things a little bit, we've gotten another functional, 2 new functional groups here. We got to update our priority list here. Remember that what happens is if you have, for example, an alcohol and a ketone in the same molecule, you're going to refer to the higher priority group by its suffix, but the lower priority group now gets referred to by its prefix. So previously, the only time that we had really ever seen this, alcohols were always the highest priority group, so they were always that all ending. Now we have some functional groups that are a higher priority. 2 other things to note about this chart. The aldehyde and the ketone have the same prefix to refer to. You're essentially just referring to the location of that carbonyl carbon. At this point, the aldehyde is the highest priority functional group that we know. So we're not actually going to be in a situation where we use that for an aldehyde yet. It's kind of top dog at this point. That won't be the case when we introduce carboxylic acids, but we'll cross that bridge when we get to it. And then also, I guess, note that aldehydes are higher priority than ketones. So if you have both of those in there, your ketone group would be referred to with the oxo suffix, while the aldehyde still keeps its all ending. Okay, so let's see some examples of these. First of all, one other thing I wanted to point out is how you would refer to dials or diones, right? When there's 2 functional groups in there. So for this particular one, 1, 2, 3, 4, 5, our parent chain is 5 carbons. So it's going to be a pent something. Importantly, it's a pentane dial. Okay. Again, just to note about this one, I don't have to refer to the location of the aldehyde group. I just assume it's on the terminal ends of the molecule. I have to, of course, I have the di to indicate that there are 2 of them, so it's a dial. But then I have to include pentane dial, so it's not pentan dial. Like you might think it would be pentan dial. That just sounds weird. It doesn't sound right because you have those 2 consonants butting up against it. So you actually keep the E on the end. So pentane dial. Just to sort of hammer this home, do another example that's similar. If let's say that there were 2 more carbons on here, I know it's kind of drawn weird now. So now we're at 1, 2, 3, 4, 5. 7 carbons. So this would be 2,6-heptane dione. right? So again, just how we deal with two aldehyde functional groups or two ketone functional groups. Okay, so now, just erase that back to the original. So now in this example, we have two functional groups. One's an aldehyde, one's a ketone. So remember our priorities list here. Aldehydes are higher in priority than ketones, which means that the aldehyde is going to keep its all suffix, but the ketone is now going to be referred to as an oxo group. So this one here, so because, and in addition, because the aldehyde is the higher priority, that's where I'm going to start numbering. 1, 2, 3, 4. So this would be 2 oxo, and then it's a but because of the 4 carbons, butanal. Right. So again, this is how we're going to deal with when we have multiple functional groups of different priorities. Here our ketone, just to sort of hammer this home, this now becomes an oxo. And this group here, my aldehyde, stays the al. All right, do a bunch more examples. Here we got a ton of different functional groups going on. We have a thiol group, a ketone, an alcohol, and an aldehyde. All right, so again, if we look at our priorities chart, the aldehyde wins them all. So that's going to keep that al suffix. The ketone is going to become an oxo, the alcohol is going to be a hydroxy, and the thiol a mercapto. Right, so now, because the aldehyde is the highest priority, I'm going to start numbering at the aldehyde, 1, 2, 3, 4. And then I got to list all my substituents. Remember that when we build the name, we're going to put them in alphabetical order. So that means that it's going to start out with the 2 hydroxy, right? My alcohol group, we used to refer to it by the ol suffix, ol suffix, but now that it's in a molecule with a higher priority group, it becomes the hydroxy prefix. 3 oxo, that's what my ketone becomes. 4 mercapto butanal. All right, and then just to do another example here, where we're going to have this double bond in here. All right, so now I have an alkene functional group, a thiol functional group, and the aldehyde. The aldehyde is, of course, the winner, as we just saw. So I'm going to start numbering there. 1, 2, 3, 4, 5. Okay. I guess I got to worry about stereochemistry of this particular alkene as well. I have this is my high priority group, and this is my high priority group. So that's going to be an E functional group, or E stereochemistry. I don't think I included that on the slides. So it is 3E. And then putting these in alphabetical order, I got the 2 mercapto, 3 methyl pent. Oh, whoops, that's not correct. Oh, it's in there twice. I get it. So one of these would have to go, right? So you would either get rid of this 3 here, and it would just be mercapto methyl pent 3 enal. So let's just do it that way for right now. Right, here's my double bond being referred to at the 3rd position. And I don't have to indicate the position of the aldehyde group because it's always on that 1st carbon. And then, of course, I have the 2 mercapto here. Another way that we could have done this is if I put the 3 out front there, I wouldn't have had to put it in there. But importantly, what I really wanted to drive home with this example is the stacking of these suffixes. You have the En to refer to the double bond and the Al to refer to the aldehyde group. Okay, so now let's just do an example with a ketone and that double bond. Again, of the 3 functional groups, which one's the highest priority? It's going to be the ketone. So I'm going to make sure that it gets the lowest possible number. So I'm going to start on this direction. Okay. For this double bond, also, did I forget the stereochemistry for that? No, I didn't. Okay, great. So that would be a Z stereochemistry for that double bond because the two higher priority groups are on the same side. This one's high and this one's high. Okay, so then I'm going to start listing. So I start off with 5Z and then 4-hydroxy. That takes care of my alcohol group. 5,6-dimethyl. And then oct, because my parent chain is 8 carbons long, 5-ene-3-one. Okay, so this is what we have to do when we have these names where we're stacking suffixes where we both have to include the letter. Remember over here, because it was an aldehyde, we could kind of get away with putting the numbering for the double bond out front. That isn't always the case, as is the example here with the ketone and the double bond. So I have the position of that alkene group, 5-ene, and then the position of the ketone 3-one. Okay.